Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here is another video in solve problem video in Engineers in Progress. And these types of problems, the light will tell you your future, your engineering preparations. If you want to really develop your skills in math, then try to solve these problems if you want to solve these problems by your own by pausing the video. So first problem on geometric problems. This is the third video on geometric problems. The principles are already there, though some of the principles here should be known beforehand or should be known by you, even without the discussion of the principles, complete discussions on the geometric problem principles. So the sides of a triangle are in the continued ratio 3 as to 5 as to 7. Twice the longest side decreased by half the sum of the other two sides is 30 cm. Find the perimeter of the triangle. So we will equate the perimeter to 3x plus 5x plus 7x, where x is the common factor for the ratio of the sides. So 3x plus 5x plus 7x equals perimeter, and that is 15x. Then to solve for x, let's have to translate the second sentence here. Twice the longest side decreased by half the sum of the other two sides is 30. So meaning to say 2 times the longest side is 7x, of course. Then minus 1 half the sum of the other two sides, minus 1 half of quantity 3x plus 5x. That's the sum of the other two sides. Then equate it to 30. So 14x, this is 1 half of 3x plus 5x is 4x. 14x minus 4x is 10x equals 30. So that means x is 30 over 10 or 3 centimeters. Therefore, the perimeter is 15x, 15 times 3, and that is equal to 45 centimeters. Problem 27. A piece of wire of length 72 cm is cut into two unequal parts. Each part is bent to form a square. It is found that the total area of the two squares is 194 square centimeters. Find the difference between the sides of the squares. So this is for higher thinking, a little bit higher thinking skills, and you need your calculator here. The solution would lead to quadratic equation. So it is out of topic, out of context. But for engineering students, you should also be familiar with the quadratic equation. And secondly, for engineering students, the calculator is available. Although you're not forced to use quadratic equation here, you can use the calculator for finding the roots. For high school students, you may use the technique on completing squares to determine the roots. So x is the longer piece, so 72 minus x should be the shorter piece. Since they are bent to form a square, the dimension of the square for the longer piece is x over 4. You divide that by 4 because the perimeter is 4 times the side. So the side is x over 4. The shorter side would also be 72 minus x over 4. And the area is 194. So area is the square of the side, so x over 4 square, then plus the square 1/4 of this, then square, plus quantity 72 minus x over 4, quantity square equals 194. So simplifying, this is x squared over 16, then 72 squared using your calculator, then middle term 100, negative 144x, last term x squared divided by 16. 72 squared is 5184 minus, then minus 2 times 72x, 144x, plus square of negative x, so x squared over 4 squared 16 equals 194. Multiply everything by 16, so this is x squared plus 5184 minus 144x plus x squared equals 194 times 16 is 3104. Simplifying, x squared plus x squared is 2x squared minus 144x, then 5184 minus 3184 is 2080 equals 0. Dividing everything by 2, so x squared minus 72x plus 1040 equals 0. So if we factor this, factors are x minus 52 and x minus 20 equals 0. So using the quadratic equation, or you factor this as x minus 52, x minus 20 equals 0, then you'll get x 52 cm, the shorter piece is 20 cm. Therefore, the longer dimension of the square is 52 over 4, and that is 13 centimeter, the longer side of the square. And the shorter square, the side of the smaller square is 20 over 4, and that is equal to 5 cm. So if the shorter the side of the smaller square is 5 cm, the difference of the sides therefore is 13 minus 5, and that is 8 cm. So the difference is 8 centimeters. Problem 28. The area of a rectangular room is unchanged if the length is decreased by 2 feet and the width is increased by 1.5 feet. If the length of the room is 1.5 times the width, find the perimeter of the rectangular room. So we have here the perimeter, which is 2 times quantity b plus h. But before that, the area remains unchanged, base times height. And it is also quantity b minus 2 times h minus 1.5 equals bh. So perimeter is 2 times b plus h. That's our working equation for finding the perimeter. Area is bh. Area is unchanged bh if the length is decreased by 2 and the width increased by 1.5. So bh equals quantity b minus 2 times h minus plus 1.5. Simplifying, bh equals bh plus 1.5b minus 2h minus 3. Cancel out bh, so 1.5b minus 2h equals 3, or 3 equals 1.5b minus 2h. Then translating this second sentence here, if the length of the room is 1.5 times the width, so that means b is 1.5h. So replace b here by 1.5h, so 3 equals 1.5 of 1.5h minus 2h. 1.5 square h is 2.25 minus 2h is 0.25h, or h over 4. So 3 equals h over 4. So h is 3 times 4, so h is 12 feet. And the base is 1.5 times 12, so it is 18 feet. So the perimeter is 2 times quantity 18 plus 12, and it is equal to 60 feet. Problem 29. What is the sum of the interior angles of a convex pentagon for a regular pentagon? Determine the measure of one interior angle. So the sum of the interior angles of a convex polygon is in general n minus 2, quantity n minus 2 times 180 degrees, where n is the number of sides or the number of corners. In this case, for a pentagon, it is 5. So summation of interior angles is equal to n minus 2 times 180 degrees. That's a general formula. So n is 5. So summation of interior angles of a pentagon is 3 times 180 degrees, and that is 540 degrees. Now for the second question, if it is regular, then each interior angle is the same. So there are 5 interior angles, so 5 times theta equals 540. So theta equals 540 degrees over 5, and that is 108 degrees. Problem 30. Each of the sides of an equilateral triangle measures S units. Express the area of an equilateral triangle in terms of S. Determine the area and perimeter of an equilateral triangle of side 12 centimeters. So first, let's derive the area in terms of the side. So this is an equilateral triangle. If we drop an altitude from this corner, from this vertex here down, this base will be divided or bisected by that line, and the line is perpendicular to the base, and therefore this is S over 2. We'll call that H, S over 2, S over 2. So area equals 1 half base times height, where the base is H, is S, and height is H, so 1 half is H. Then let's express S in terms of S by Pythagoras theorem. H is square root of S square plus S over 2 square. So area equals 1 half BH, where base is base is H, S, and H is H. So expressing H in terms of S by Pythagoras theorem, H is square root of S square minus quantity S over 2 square. And that is S square minus S square over 4. So that's that's 3/4 of S square. So H is square root of 3/4 of S square. So it is S square root of 3 over 2. That's the altitude. Substitute here where B is S. Area is 1 half of S times S square root of 3 over 2. Therefore, the area of the equilateral triangle in terms of the side is square root of 3 over 4 S square. And you should recall that, remember that. If you cannot remember that, you should be able to derive that formula. Perimeter, on the other hand, is just 3 times S. So for the second part, area therefore is square root of 3 over 4 times 12 square. So expressing the area as exact, it is equal to 36 square root of 3 square centimeters. For the perimeter, it is 3 times S. S is 12. So therefore, perimeter is 36 centimeters. Problem 31. An isosceles right triangle has a perimeter of 58.04 cm. Determine its area. Note that the triangle is isosceles right triangle. So meaning to say the equal sides, which we call S or X, are perpendicular to each other. So the area is 1 half of X times X, or 1 half X squared. And the diagonal, the perimeter is simply X plus the hypotenuse, which is X square root of 2. So perimeter is X plus X square root of 2. These are the equal sides of, or equal legs, perpendicular legs of an isosceles right, take note, isosceles right triangle. So the hypotenuse is square root of X square plus X square, so X square root of 2. Perimeter is 58.04 equals 2x plus x square root of 2. Factor out x. 58.04 equals x quantity 2 plus square root of 2. Therefore, x is 58.04 divided by quantity 2 plus square root of 2. So x is 17 cm. Area is 1 half x square. 1 half x times x. So therefore, it is 1 half of 17 square. And it is equal to 144.5 square centimeters. Problem 32. Express the area of a square in terms of its diagonal. Denote the side of the square as S and the diagonal as D. Also express the perimeter of the square in terms of the diagonal D. So let's draw a square as our guide. Area is S square, and S square plus S square equals diagonal square by Pythagoras theorem. Area is S square plus S square by Pythagoras theorem equals D square. So 2S square equals D square. That means S square is D square over 2. So the area of the square in terms of the diagonal therefore is S square, and S square is D square over 2. So the area is 1 half D square, or D square over 2. Then for the perimeter, it is 4S, and S from this equation is D over square root of 2. So d over square root of 2 times square root of 2 over square root of 2. So it is 2 square root of 2d. Perimeter is 2 square root of 2 times the diagonal. Problem 33. 300-foot fencing material is used to enclose a region in an open field. Determine the area that this fencing material encloses for the following cases. A. Rectangle of length 100 feet. B. Square. C. Equilateral triangle. So if it is a rectangle of base 100 feet, so area is BH, then perimeter 300 equals 2 times quantity B plus H. 300 equals 2 times quantity 100 plus H. So 300 divided by 2, 150 minus 150. So H is 50, the width. Therefore, the area is 100 times 50 for the rectangle. If the area to be enclosed is rectangular in shape and the length is 100 feet. So the width is automatic is 50 feet. So area is 100 minus 100 times 50, so 5,000 square feet. Then for part B, square area is side square and perimeter 300 equals 4S. So that means S equals 75 feet. So area therefore is 75 feet quantity square. So the area is equal to 5625 square feet. Then lastly, problem 30, letter C, equilateral triangle. The area of the equilateral triangle from this problem 30 here is square root of 3 over 4 S square. So square root of 3 over 4 times S square, where perimeter is 300. 300 equals 3S for equilateral triangle, so S is 100. The side of the equilateral triangle is 100. So square root of 3 over 4 times 100 square, and it is in decimal 43 square feet. Then last problem, 34. Actually, it is supposedly a continuation, but I just make another problem, last problem. A 300-foot fencing material is used to enclose a region in an open field. Determine the greatest area it can enclose. So from the preceding experience, a square is one that has the greater area here, greater area. A square 5625 against rectangle and equilateral triangle. So that means that gives us the idea that if we increase the number of sides, then the area will increase. Therefore, the increasing the number of sides of a regular, because a square is a regular pentagon supposedly with 4 sides, regular pentagon, hexagon, septagon, and so on and so forth. So if the number of sides approaches infinity, it is approaching a square. Therefore, for a given perimeter, the shape that will enclose the greatest area is a circle, because the regular pentagon will approach a circle if the number of sides approaches infinity. So circumference 300 is 2 pi r. R therefore is 150 over pi, and the area of the circle is pi radius square. So pi quantity 150 over pi square. Using your calculator and in expressing the answer as a whole number, it is equal to 7162 square feet, which is very much greater than 5625 square feet. So that shows that the shape of a region that will enclose the greatest area for a given perimeter is a circle.